we have NetApp topics today, and maybe we can go ahead with that.
Yeah, just to start, welcome to the last day of the PTG. You can add your name to the attendees list for the Friday section, and we can get started with the NetApp SVM scoping support for NVMe. This topic. Yes, Evan, please go ahead.
Yeah.
Yeah,
So
we have
this is
Girish.
hi everyone. Yeah.
Yeah.
Hello everyone. This is Girish from NetApp. Okay. So um, um, so today I'm going to present the fix for the SVM scoping support for NVMe. So as we know, actually we have two kind of user scoping in the ONTAP. One is the cluster level scoping, and one is the SVM level scoping. So cluster level scoping means, and there also you have two things. Either you have a admin privilege, or you are creating some other user which we are giving some privilege for executing few things on the resources. So with the cluster scoping, this functionality for NVMe, everything is working fine. But with the SVM scoping, so SVM scoping means we have concept of the tenant actually. So you can compare our ONTAP with our EX6 server. So like EX6 server, we have with different VMs, and those VM we are giving to the end user. Similarly, we have the ONTAP. On the top of ONTAP, actually, we can create the SVM and we can give those into some user, or they can mount the leaf and they can write the data. So it's work in the tenancy mode, means one SVM cannot see the other SVM data. So with this SVM scoping user, actually we have this user, we have limited privilege to do some operation on tap. So the problem here actually with the SVM scope user, our driver initialization is failing. This is the first problem. So it's failing while fetching the performance data. So what we are going to fix as part of this one, first thing that we are making sure that our driver initialization will be successful, and our volume pool, everything, it should populate all the required data for the SVM scope user, and other functionality which means SVM user can perform actually. We will test those on and make sure that all the functionality should work fine. So this is the problem which we are going to fix here. And how we are going to fix here actually, so we need to check either we need to add more REST or API support, ZAP support for the SVM scope user. So how to get those performance data, and if they don't have a capability, we need to check with the ONTAP team if they don't have the capability. So we need to might be skip those check while driver initialization. So those all things actually I need to fix as part of this feature. Yeah. So that's it from my side. This is a small thing, and hope so will complete this one in this release.
So basically, want to implement this SVM scoping for NVMe, like the two cases you mentioned.
Right. Yeah.
Fix initialization and implement and test all the functionalities for it.
Right. Right. Ideally, it should work, but if some means right now what we are hitting, actually we are hitting that driver initialization issue. But might be once we fix that point actually where it's where we are hitting that getting the performance data, we might be hit some more issue. Well, means like first step we're done, we need to see what is in the second or third and fourth step for initialization. It might fail there also. So we need to fix all those things actually here. Apart from that, then whatever the limited functionality we have, it's supposed to work for the SVM scope user. We need to test those one, and in case if it is failing, we need to fix those one. So these are all the things.
So what is the end user impact of this scoping? Like, is this a feature of NetApp and how end users use it?
So normally, so as I told that our SVM is like the VM on top of the EX6 server. So we create the SVM, and it's kind of work in the tenancy mode. So we create the SVM, and with the SVM actually we have the different export path and those all things. So we can give that SVM that has its cluster management diff and other data leaf also associated with that SVM. So we give that one to the end user. So end user can mount that volume and he can write that one in the some particular whatever the associate aggregate of that SVM. So this is the feature actually which customer is using, but on tap point of view, it's customer using on tap point of view, but OpenStack point of view actually it's breaking for the SVM scope feature, which you need to fix in this release.
So to add to that, right, cluster is like I mean, whatever NetApp is shipping, right? It is a cluster, it is a storage server. It is a very big box. So what we will do, right? So not everything is given to one user. So what the customer, when they buy, what they will do, they slice the storage server into multiple virtual storage servers. Okay, SVM stands for storage virtual machine. So it's like virtual storage servers. So they create like maybe hundreds of virtual storage servers. So this is given to example within a company, right? There is a HR department, there is a production department, there is a sales department, right? So they can create a storage V server, they give it to them. So that's how we are creating tenancy. So only that admin, right, the administrator of that lab, right, only they will only have the storage admin will have all the privileges, but the people who are consuming it, right, and they will not have all the privileges. So everyone will get only that low level permissions only with respect to that particular storage V server. So they will not get even beyond that. So only for those kind of users, if they try to use NVMe, right, so things are breaking. Today also, if they use the super user permission, everything will work. There is no problem. But say I got only a subset of V server, right? The small storage server, the sliced storage server, and if I get full credential for that sliced storage server, but the things will not work, and that's what it is. The SVM scoping is all about, and that we will be implementing. Yeah. Okay. So it is based on tenancy of NetApp. Yeah.
Yeah. So it's failing right now because might be there is some missing. Might be we need to invoke different APIs, different REST, or there might be some privilege issue, and which means privilege issue to executing the particular REST and JAPI for that particular user. So we need to go through the means all the step and fix those all workflow here.
Rajat, all other protocols it is working, only for NVMe it is failing.
So is it like a pool in the NetApp? Like we can consider it. So if from an OpenStack perspective, if I define a Cinder backend, then it will point to a SVM, right?
Yeah.
Yeah. Okay.
Cluster
So
yeah.
So in case of NVMe right now, with OpenStack, users cannot use because they need to access this SVM and then they can't. So okay, yeah, I understand the use case.
Okay, thanks.
The idea sounds good to me. I don't know if anyone has any objections to that.
This is specific to NetApp actually, and there is few customer which is hitting this issue. So I think we need to fix this one from NetApp driver point of view.
Yeah, I see. And it's, I think, very important since it's blocking the usage of NVMe for customers. So
Right.
okay, if there are no objections, then we can move to the next topic, which is again by NetApp, the ASA next support.
Rajat, I have a slide deck for this. If you don't mind, I will share my screen.
Yeah, sure. I will stop sharing.
Can you guys see my screen?
Yeah.
Yeah. Okay. So today I'm going to present NetApp ASA R2 support for Cinder driver. So what is a NetApp ASA R2? It's a R2 version of NetApp ASA, which is a pure block optimized SAN only offering based out of all flash array. It's intended to provide high availability and reduce power usage. It's a cost-effective solution and highly performant and used for large-scale deployment. It's intended to provide microsecond latency with storage unit can be provisioned up to 300 terabytes of storage. And also it is providing app-specific data protection. For example, storage array can aware of what is the app is going to use the storage unit. Based on that, it can provide a customized application aware data protection. For example, we already have VMware aware and Oracle, SQL, other apps also has app aware data protection inbuilt baked into the ASA R2 NetApp system. And also it's a tailor made for high performance workloads like ERP, ERPR, data analytics, and also next generation AI systems can use this high performance offering from NetApp for their workloads. And this is the brief overview of NetApp ASA R2.
ASA stands for All SAN Array. So it's a sandbox. Yeah. So only sandbox. Yeah. Known as.
Earlier we have combined offering of both SAN and NAS. This is only specific for SAN. Okay. So what are the changes NetApp is going to do for all SAN array? So by default, we are going to have default tenant-based storage virtual server created, data virtual server created by default, and all SAN protocols are enabled, and the networking and the default settings are enabled for that storage virtual server. And we are going to introduce a new industry standard storage unit, which is going to represent both iSCSI, LUNs, and namespaces, NVMe namespaces, which are present in earlier ONTAP systems. And also latest standards of TLS are supported, and by default, thin provisioning is enabled for these storage units. Earlier, we have support for both thin and thick provisioning, and for this offering, we have only thin provisioning to support the to meet the existing industry standard. With these changes, we have introduced a new REST APIs for this ASA R2, and there are whatever is existing SAN related workloads. There are few changes in the way the REST API is going to invoke in terms of method, and the attributes are changing. And also earlier we have support for JAPI and REST. With ASA R2, we are sticking to the latest industrial standard. Only REST-based APIs are supported. And also, when it comes to data protection, earlier we have data protection is supported at volume level, LUN level, and at SVM level. This confusion is removed, and we have a consistency group, which is going to be on top of, it's a virtual entity, which is going to present on top of storage unit, which is going to manage both quality of service QoS and data protection workflows. So earlier, when we have combined SAN and NAS offering, we used to have storage operating system called ONTAP 9. Now, only for ASA R2, we introduced a new OS called ONTAP X. So what it does is to make SAN workflows optimized and easy to provision. Some of the objects which are present in earlier OS are reworked, and optimized. For example, instead of aggregate, we have a storage pod, which is a virtual entity spread across all clusters. In high availability configuration, we can have multiple clusters, and each cluster is going to have its own aggregate, and real storage is associated with aggregate. In case of NetApp X, we have storage pod, and all block storage is attached to the storage pod. When we create a tenant-oriented storage virtual machine is going to have Flex aggregate. It's also virtual entity, and it's going to have partitioned storage associated with the Flex aggregate. When user provisions a storage unit, logical unit is created, and to maintain the backward compatibility, hidden volume is created. It's in one-to-one configuration. And also to support QoS and data protection, we are going to have consistency group also by default created for the each LUN. So these are the architectural changes. Next, so with these changes, right, we are anticipating all current workflows associated with combined NetApp Cinder driver. We are going to see impact in each workflows. For example, discovery, we are going to have by default data SVM is created with the different privileges. There are additional privileges and also some deprecated privileges. So we anticipate a discovery workflow is going to be needs to be updated to latest changes in the NetApp X and ASA R2 NetApp. So to accommodate new objects. And also there are capability changes. For example, right now thin provisioning is supported, but there is no thick provisioning support available. So discovery, we are going to rework for new NetApp ASA R2. Similarly, provisioning, earlier we have for each protocol, right? For iSCSI and FC, we have support for LUN, and NVMe, we have object called namespace. Those will be replaced with the storage unit. So we need to update our provisioning workflows also. Similarly, in the provisioning workflows for quality of QoS and data protection, we need a consistency group. So we need to create all associated objects during storage unit creation for Cinder volume. Similarly, so once we have that provisioning objects available, right? Other workflows like backup, QoS, those are also not going to change now, because earlier we have backup at LUN level or namespace level. Those are going to be updated to consistency group level. And also when it comes to QoS, right, we have a new concept called QoS template introduced in ASA R2, that is NetApp X. So those QoS workflows also we need to rework to support this latest QoS templates. Similarly, earlier we have one flex volume can have multiple storage LUNs associated. When we restore, right, it's going to restore to vVol. In case of latest ASA R2, there is a one-to-one association between storage unit and vVol. So when we restore, it has to be new storage unit altogether. So that workflow also we are anticipating a change. Similarly, all protocols we need to rework to support new architecture. Similarly, mirror, whatever the other objects associated, right, we need to accommodate to the new architectures proposed from NetApp ASA R2. So this is at a higher level. So any questions I can take? So
one question I have, so all these things that we are discussing, like changing the name of to storage unit in place of LUN or namespaces to standardize things, these are all going to be happening on the NetApp side, right? Like on the storage array side.
Yes. So all these changes are going to be at the driver level, right? And
Okay.
we're going to modify a unified driver, whatever we have right now, to accommodate ASA R2 from NetApp.
And the ASA R2 is it's a hardware thing, right? Like it's a new.
Yeah, hardware thing, and also there is a architecture change.
Yeah. So if customers are going to migrate from their old hardware, like
No. Right now, NetApp itself is not supporting older hardware to ASA.next. Upgrade is not supported by NetApp. So maybe through Cinder, maybe we can migrate our specific volumes. Maybe altogether, all workloads cannot be migrated to from old ONTAP to new ONTAP at ONTAP level.
So the data would be copied. We have something called, the foreign len import, len copy. So data would be copied, but it is not like an upgrade, like from X to Y. Okay, but the data can be copied from X to Y, and you can make use of that after that.
Yeah, I can understand. Like this is a new storage architecture which
Yeah.
NetApp is offering, and it only offers like greenfield deployments.
Greenfield, yeah.
I just wanted to understand like what will happen in the driver. So right now the driver supports all the code that is to interact with this ONTAP9 array, and now we are going to implement all the code that could communicate with the new ASA R2. So the code is going to coexist, I think, like depending on the NetApp array version, whichever we get, we will be doing calls specific to that.
Yes, Rajat. There is a new REST API which is going to give the details whether it's a ASA R2 or a combined offering from NetApp. So that based on that information, we have to logically go to different sections of code.
Okay. And is this product available? Like, have customers adopted to it already?
Yeah, this is in the month of September last week. So October 1st week, it is alive. It is there in the market. And when people buy, but we will not support OpenStack at the moment. That's why we are prioritizing now.
Okay. Yeah. Thanks. I got it. What's the idea behind this?
So one maybe out of the box question. And initially we thought about having another NetApp driver, but that is defeating the purpose of we have got unified driver. But the changes are like a little complex, right, that you see, right? So you recommend we can stick to the same driver and we can have sub logic there, right? To based on the platform we detect, and we can just execute the relevant operations in ONTAP and perform them. Yeah,
it depends on the changes mainly. Like if for every operation we are going to have a separate call, like if I want to create a run or a snapshot or anything, and we are going to have different REST API calls for everything, then a new, I don't know, driver, but a new interface, a REST call interface for that would be more suitable.
Yeah, new interface. Yeah, okay. Yeah.
And if they are going to reuse, like again, like if the old code could be used for this new array, then I mean, maybe we can, I don't know if you can submit a POC or something, because I have no idea like how this interaction is going to look like.
Okay.
Yeah, sure, Rajat. We can start with the POC. Meaning, what you expect from POC? We can present.
No, like the basic thing working, like using the interface approach, right?
Yeah.
But even I expect 50% of the REST API is going to be same for ONTAP 9 and ONTAP X. So maybe, so that's what he's recommending, not another driver, but another interface. Like today we got one for C mode, right? Maybe one more for C mode, ASR to something like that. Yeah. Develop something, and if it is working, then we can follow the approach. That's what he means.
Yeah. In that case, Saravanan, I can think of one simple workflow. we can have a discovery workflow plus a single provisioning, like Cinder volume create. If we can show, we can submit code with a discovery plus volume creation, right? A single workflow. Rajat can go through the code and suggest if you can see the PR and suggest something on top of that.
Rajat, yeah, that way, like we'll follow right thing. Yeah, rather than we implement everything, then scrap it, right?
Yeah, sounds good. Just one more question I have. So, like, we are standardizing the logical volume here, like either it's irrespective of the protocol, like as you mentioned, like learn namespaces, everything will have the same name storage unit. But when OpenStack wants to map a volume to any host, then it requires specific connection information. So that it will still provide, right? Like for ISP, fiber channel and NVMe, it will have, say, different formats, right?
Yes. Multiple protocols are supported by single SVM. Earlier, we see that limitation with the earlier ONTAP 9. When we create SVM with a mixed protocol, right, it used to file with NVM. But other protocols are supported. Now, there are clearly mentioning that all protocols are supported for a single SVM. So workload should cater all the available protocols.
Okay. Yeah, if you can at least implement the code for like creating a LUN and attaching it, that will be enough to understand like how this is going to look like.
Sure, Rajat. Yeah. We'll take that first step and we can, based on your comments, right, we'll do the further discussion, or we can go ahead with further implementation.
Yeah. Even other codes, like everyone in the community can comment on how this should look like. Yeah, sounds good to me.
Yeah, thank you.
Okay. No, if no other further questions, I will start sharing. Thank you. Thanks for your time.
Yeah, thanks. Yeah, if there are no other questions, then again we can move to the next one. I think you have two more topics from NetApp side to present.
I will take control, Rajat. Yeah, I need
Sure.
to flip to some slides. So yeah. Let me know when you see my screen. Yeah.
Yeah, it's visible.
Oh no. Okay, this one will be always there. Okay, yeah. So we have two more topics. You see my Etherpad, right?
Yeah.
Yes.
Yeah. Okay. Yeah. So first one is SnapMirror sync support, and I'll explain what is that. And next one is multiprocessor support, and yeah, we'll go to that SnapMirror sync support. Yeah. So sync mirror, it is basically for a replication. And today in Cinder, right, and Cinder supports replication, and even NetApp Driver, we have coded that for replication. And replication all about, we have got something called primary, and yeah, we have got something called primary. You see my slide deck, right?
Yes.
Yeah, we got something called primary, and maybe here the Cinder volumes will be there, and all the volume, whatever written here, right? So that can be like we'll replicate that to the destination, and that's how it is today. And so that is perfectly working fine. But whatever we have coded so far in NetApp Driver, right? So it is based on something called asynchronous replication, and we have not used synchronous replication. So this part of code is not there. So the difference between asynchronous and synchronous, right? If you look at asynchronous, what happens? And whenever somebody is writing to the primary source storage, right? So this is written, and acknowledgement is given back to that client. So this is done. And later there is some schedule we have created in ONTAP. And based on the schedule, right, the data is replicated to the target storage. And maybe the schedule may be like a 1 hour, or schedule may be like a very aggressive, or maybe like a 1 day, or it depends on the like what user wanted. And yeah, so if there is something like they have not configured properly, right? So that point of time, any disaster happens on the source side, and so those whatever the data, right, that is not copied according to the schedule, right? So all the data is going to be lost. So that's a problem we are having with asynchronous replication. And as a synchronous, this is something implemented maybe like a few years back. And synchronous replication all about the moment we are writing data to the primary storage, and at the same time, exactly when you see that whenever we are writing, right, so the data is even replicated to that secondary immediately. So there is like it is not waiting for any schedule and all. And even acknowledgement is given back by both the destination storage as well as the primary storage. And this is what all about synchronous mirror, and we call even synchronous replication. And this is what we are going to support in the Epoxy release. Yeah, and if you look at, there are a couple of modes we have. One mode is called, we'll maximize that. Yeah, one is called sync mode, and another one is called strict sync mode. And the sync mode is all about, so even though like sometimes even your secondary may not be available, there may be some problem, but your primary is available. So even though if secondary is not available, right, and we will keep writing to that primary. So example, if you see here in sync mode, right, even if that secondary storage does not complete, maybe there is a latency between primary and secondary, and still like the application will continue writing to the primary. So that's what sync mode. And the strict sync mode, right? So this case, like even when the writing to secondary is failing, right, we will not even allow the client to write to the primary. So that's what we call a strict sync. So these two modes are available for the synchronous SnapMirror. And I'll go back to that Etherpad. Yeah, so that's a, yeah. So as I mentioned earlier, like so we lack support to create a replication using this SnapMirror synchronous technology, and that's what we'll be adding in Epoxy release. So today, if you look at, right, and we are having these two options in cinder.conf. We provide replication device. This is there for every vendor. For NetApp specific thing, we are having another configuration. It's called a replication aggregate map. So based on that, we will create the destination volume in so-and-so aggregate. So that's why we need this field. And this is how it is today. And our proposal, right? So what we will have, so we will implement something. We will have 3 more options in our configuration file. So one is called the replication method, and whether it is async or sync. And today by default, it is async. That's what default, it is optional. Even if you're not provided, right, you'll always follow the synchronous SnapMirror relationship. But if you provide sync, right, we will make sure like what replication we are creating between primary and secondary, we will use sync. And the next one is called sync mode. This option is needed only like when we pass this as sync, right, then only we need this option. And the sync mode, again, we have these 2 options, sync or strict sync. And that's what I explained in that PPT, right? And so accordingly, whenever we create a replication between primary and secondary, we will make sure like we'll apply this policy there. And the third one is there is something called a common snapshot schedule. And so as I mentioned, maybe schedule is not important for a synchronous mirror because every data is written to primary, it is replicated to secondary. But there's something called recovery, right? When primary side goes down, so the secondary should act like a primary, and there's a recovery time. So if you want a very fast, quick recovery time, right? So the snapshot is going to create a major role there. And so this, again, it's optional field. And so user can feed the value whatever they wanted. So whenever we create a replication between primary and secondary, we make sure like what is the schedule we need for common snapshot. And this is very important for quicker recovery, and the user can pass this input. So these 3 other additional fields we expect a user to pass. And then accordingly, based on the values, right, when we create a replication between primary and secondary, we make sure like a sync is created there. And yeah, that's a proposal. And the benefit, right, maybe as I explained earlier, that data loss would be going to be 0 because we write immediately to the destination. And but if you look at RPO, right, the recovery point objective, generally like SnapMirror supports 0 RPO. But in case of Cinder, right, and the failure is not triggered automatically. And so we have to use the command, we have to trigger the command manually, like we have to do Cinder failover host. So until the user does Cinder failover host, right, and that secondary is not acting like primary. So that problem may be there, but anyway, it depends on this. Maybe user can have some script, or we can provide a script to that customers. They can keep watching that, and they can, based on that, they can even execute this command. Then they can trigger failover at Cinder side. And so this also provides a foundation for our another feature called SMBC. SMBC is nothing but a snap mirror for business continuity. So a lot of Europe customers, they wanted this. And when we support this snap mirror synchronous, right? So on top of that, we can provide some custom solution, and we can provide to those customers so that they can even go for SMBC. We can enable SMBC in that environment. Yeah, that's all about the sync mirror support. And if you have any questions, please go ahead.
Yeah, one question I have. So if I'm configuring like strict sync replication,
yeah,
so the volume needs to be copied between primary and secondary instantly at the same time. Before that, the operation won't succeed. So this will certainly have some performance impact, because previously we used to write one, now we are writing two volumes, like the primary and then to the secondary.
Yeah.
So just to make sure in a large done, the request doesn't time out, like have we considered that case?
Yeah, actually, if you look at from Cinder perspective, our Nova VM, right, it is writing only to primary. So Nova is not doing anything, writing to that secondary, I mean, the target storage. So between this primary and secondary, this is done by ONTAP. So we have ONTAP system, primary storage system, this is ONTAP destination storage system, I mean, target storage system. So we expect, generally we want whenever somebody is configuring synchronous snap mirror, right? And we have our technical report in place, like the distance matters and the latency matters. And example, when the packet goes here and when the acknowledgement comes back, right, we expect it should be like a less than 10 millisecond. So only when those things are there, right, then only we expect them to configure sync mirror. Otherwise, we will ask them don't to go for synchronous snap mirror. Yeah, there are a lot of factors involved, you are right. And there may be performance impact, but it is not going to be visible from Nova side. And but yeah, maybe in worst cases, even if customer is configured, but when Nova is writing to this primary storage, due to some problem, when this is not getting into secondary storage, yeah, Nova will see the problem. Nova will see that, okay, the writing is not happening, right? Yeah, that time, those cases, yeah, we may see problem in our OpenStack VMs. Yeah, that case, the user has to fall back to asynchronous mirror, like this one, they have to go for it.
Okay.
Yeah.
So basically, there are like certain checks to be done to
yes, to enable this feature. Yeah. Even this is also license based. Yeah, and user who wanted sync mirror, they have to enable with the license, and so yeah, there will be NetApp support team. They will work with them, yeah, to configure that. Yeah.
Okay. And regarding the testing for replication, like so NetApp currently supports async replication. So to test this, like how did we go about the deployment? Like, did we use it with OpenStack to create two different clusters at two different locations, and then like shut down one of the clusters and perform the failover, and like after the cluster is up, then fail back? Is this kind of testing being done? Like, can you describe the testing, how it was done for async? Like,
this is coded long back, but recently when we worked on high availability feature, right, that last Dalmatian release for ASKC and FCP, we have done that, like how you said, right? Like, yeah, you are right. We have got these two systems, and yeah, so what we did, like, we made sure like we kind of everything is working over that IP, right? So we just shut down that IP address here, so that the writing is not happening, and then manually using the failover host command, we failed over to this one, and then this is acting like proxy, right? I mean, Cinder is making this secondary as a proxy, primary storage proxy for the primary storage, and we see that it is happening, and then Nova VM is able to write continuously to that storage. And but what we stuck there, right? Failover is properly fine for us, but when you tried failback, right? Failback, we have not seen it is properly working. But I don't know whether it's a problem with our NetApp driver or it's a problem with the general. I don't know that. But failback, we had some tough time, and so probably like when we work on this feature, right, this time, and so because we'll make some changes to that existing replication code as well, and we will make sure like we will test both failover and failback, having the two clusters in place, and both primary and destination place, and we will shut down the primary, and we'll make sure like only secondary is up and it is serving data. We'll also do failback, and we'll check how it is performing. Yeah, the way you described, we are going to do the same way, and this time we can populate the results for you, Rajat.
Okay. And is the failback triggered automatically, or is there? I'm not
Not
sure.
failback. We tried doing manually only. It is not triggered automatically. That is the first thing. And even we triggered manually also. Looks like we have to make some DB changes to make it work. And so we didn't see like it worked automatically, the failback. That's a problem we saw actually very recently. Even for this PTG also, I explored that async thing, and I saw that problem. And maybe I don't know where I'm missing some configuration. And but I can check that. I'll take this this as an opportunity, and I will cover that element in Epoxy. Also, I will write an article for the customer so that they can literally follow that to make use of both asynchronous and synchronous without any problem.
Okay.
Yeah.
Just to understand, like when the primary side comes up, then do we sync the volumes again?
Yeah, we have to resync because secondary has more data now, because Nova VM has written more data, and so we have to do resync. Resync means from the secondary the data would be again mirrored to the primary. Then primary should act like a real primary. Yeah, and yeah, I see that resync happening. I see that primary is coming up, but somewhere that writing is, that's where like I saw that it is not happening. I mean that backend only not coming up. Something like that I saw that. Yeah.
Okay.
I think we have all the notes here, but maybe I don't want to take the time. Yeah, maybe.
No, I was just asking questions.
Yeah.
I just wanted to.
Yeah, your question is valid. Yeah, yeah. Even I have that doubt. Failback, but failover is properly working fine, Rajat. There's no problem. Yeah.
Yeah. Okay. Yeah, because as I said, like it could be a problem with the Cinder as well. We don't test it in any CI because again, setting up 2 clusters is not, I think, feasible for our upstream CI. So yeah, let me know like if you need any help around at least the Cinder area of code for this.
Sure, definitely. Yeah. Okay. So no other questions, then I can move on to the next topic, or just wanted to understand. Yeah. Others? Okay, I take it as no. Yeah.
And also, I think Pure Storage has already implemented synchronous replication. Like if you want to like refer from a Cinder code perspective,
okay.
I'm not sure, but I think they have implemented it to support synchronous.
Yeah, sure, Rajat. Yeah, I will look at that. Yeah, that piece of code as well. Yeah. Okay. Yeah. Thank you for the input. Yeah. So the next topic is Metro cluster. So Metro cluster, I don't know like how many of us are really I mean, maybe the terminology may be new, but so Metro cluster is built. Maybe I'll give a little background here. Yeah. So generally, what happens like we know all the replications and everything, right? And but whenever we fail over, right? So we have to do some operation at the host side. Example, like even Cinder also we have to do failover. Then sometimes IP is changing because this is the primary IP will be like maybe like 1 dot series. Here maybe IP will be 2 dot series. Maybe some changes are there. Maybe we have to do something at the client side. We have to do remounting or detach and attach again. So all the things are there. And so like client is involved, the host is involved. So that's a problem we have in a lot of this replication concept. But Metro clusters was brought in to eliminate all the things like a host side. You don't need to do anything. Okay, and the Metro cluster is equal to this sync mirror. And so if you look at right, and this is how it is. So we have something called it's between the site. So Metro cluster is supported across like 300 kilometers or 200 to 300. You can't have Metro cluster beyond the 300 kilometers. And so example like maybe San Jose. Maybe I don't want to compare that. Yeah. So, but just assume that two sites across 300 kilometers, it can convey Metro cluster. This is very famous in Europe region, and a lot of people went for that. So this is our site A. This is a site A, and site A I've got a cluster. Like again, I got 2 node on tap. It's like again highly available. When this node goes down, the other can take it up like that it is. So this is site A, and there's something called site B. This is another site, maybe across 200 kilometers away. Here also I got 2 nodes. So what happens here, right? So whatever data I have written here, primary, right? So everything, anything I'm writing, even a small bit I'm writing here, example, the client, right? Client is writing here. So everything is like copied over a WAN to the secondary. So everything, it's like a kind of synchronous mirror only. Everything is copied to secondary. And what happens? And so whenever the primary goes down, so the secondary, right? Even the IP address. So example, what IP you are having inside, right? And so everything will be mimicked to this one. So the client, right? When the primary goes down, so client, what the client will always look for? He will always look for your FC, that zoning, or they will always look for your Ethernet IP address, right? So since IP, everything is mimicked to here, so client even will not know that, okay, there's a downtime of this primary is down. So because client will always look for the IP address and they won't write something. So since IP, everything available, right? And you can still communicate with them, and you can, like, you won't see any downtime. Okay, that's the concept of metro cluster here. And yeah. So yeah, the problem today, right? So metro cluster is like another configuration, and it is perfectly working fine in Cinder today. There is no problem. And so when both are active, right? Even I know customers are using like they configure this as one of the backend in Cinder. It is working fine. They configure this another backend in Cinder. It is working fine. So there is no problem today using metro cluster. But the problem happens when there's a disaster happens. So example, when the primary site goes down, right? So Cinder, maybe in our NetApp driver, right? So we don't have knowledge about, okay, now there is a failure happened. I mean, there's a disaster happened. It means now the data is being served by this site B, and IP, there is no change in the IP. But there is one problem we hit. The problem is mainly because, so example, if you look at this is our configuration today, and yeah. So this is our configuration today, and what we always do, we always go to the cluster, and we always go to the vServer. vServer is our storage vServer. There's a slice version of that storage box. And so what we do, right, for all my volume management operations. So it's not like a reading writing. Reading writing is always based on IP address, or SKC discovery or FCP discovery. That problem will not be there. But tomorrow, if you want to modify the volume, or you want to receive the volume, or you want to delete the volume, so we have something called volume management operations in there, right? So those things, even we discover the backend, we even upload, we even update the capability for our storage pool, right? So all will go for a task, because, so this is my configuration. What happened whenever there's a failure happened, and how metro cluster works, right? For every storage vServer, right? For every source vServer, so at the destination, we call something like -MC. We always append this extra configuration -MC. So when it is in primary side, it is MySQL vServer, it is called as MySQL vServer. But when it is in secondary, when the disaster happens, right? So the vServer is called MySQL vServer -MC. So we are adding this extra name in the tag. So what happens in the cinder.conf, we always look for the MySQL vServer, right? So this MySQL vServer will not be there because it is down. This site itself is down, but the data is being served to no VM. But we will mark, because of all these things are down, we'll say, okay, this backend is not available, and we can't do anything there. So that's a problem we are facing today. And so yeah, the proposal for that, right? And so even today, the workaround, what we ask, the workaround we give it to the user, right? Whenever the disaster happens, we ask the customer to go and change the IP address of that site B. Say this site A. Update that to site B address, and come here and update that to -MC. After they do that, right, everything is working without any problem. And so this is the manual way they are doing every time. And again, when they fail back, right, again they have to come back. Again they have to update with site A address. Again they have to update from MySQL vServer -MC to MC standard metro cluster to just normal MySQL vServer. This is a workaround they are following, and this is even annoying a lot of customers. And so for that, right, even I don't know whether this approach is really will work fine or not. That's where I need your expert opinion here. And this is what we thought through. And so we will have something like this is our backend today, right? And so what we will have, this is a typical configuration, but we will add one more parameter here. This is a new parameter we'll add. That's what we call NetApp server. So this is a primary, say this site A. This is a site A address, and this will be like a site B address. Yeah, site B storage. Yeah, storage system address. Yeah, something. Yeah. So we will have both configs in one backend, but by default we will use always this one, and we will not have any problem. Yeah, and even this my NetApp server can be like this. Similarly, for site B backend, we will have like when the site B backend is there, right? So this is, this is the IP address of the site B backend. And here the partner, right? That NetApp server MCC partner backend name will be the site A backend. This name. This is my partner. And for this guy, the partner is this one, this guy. Yeah. So like that, we will have some kind of relationship between the site A and site B. And so then we will make changes to the driver code in our driver code, and what we have to do at the beginning, right? So whenever we discover a backend here, and there are some parameters, we can understand whether it is a metro cluster configuration or not. So we'll understand whether, okay, this is a metro cluster backend. And then, so whenever, so example, so say whenever we look for this MySQL vServer, right? So what we have to do, when this MySQL vServer is not available, and even if this IP is not available, example, maybe the whole site is down, right? This also down, and this also will be, everything will be down. So ideally what we have to do, like I would assume that, and this is what going to be my proxy backend, like whatever I called out here, right? Because if you look at, check the state of MySQL vServer, if the MySQL vServer stopped the state means it's down, yeah. It is down, or even not only even that MySQL vServer, even I can check this also, if both of them are down. And this, if both of them are down, right? So what we have to do, I have to make that the partner one. So this guy should act as a proxy for this backend. I saw this proxy code is already there in the replication. And so I thought of maybe we'll make similar function to make this as a proxy backend until that normal scenario happens, like when both are up. Yeah, ideally at the beginning, both will be up. When disaster happens, this will be down, this will be up. That time he will serve as a proxy for the backend. So once the situation is back to normal, right, and both will start serving the data, the proxy should be removed. And so that's what we thought of implementing, and maybe wanted to know your opinion. Yeah, maybe if it is confusing, maybe I can explain separately, maybe in another meeting. But yeah.
Yeah, so from what I understood, like the main difference between replication and this metro cluster is that the IPs, like the whole cluster is mimicked same as the original cluster, and we don't have to do manual interventions, like outside of OpenStack at least, to like do the failover.
Yeah.
So in case of OpenStack, why do we need to update this IP to site B? Because both should have the same IP, right?
Okay. Yeah. Okay. Sorry. Yeah. So that's where the problem is. Yeah. No, that's what. See, there are two IPs, right? One is called, maybe I'll add here. We have data IP address. So this is what will be used by Nova for discovery, for iSCSI discovery and FCP, right? Yeah, for iSCSI discovery. And so this IP will not change. This is what always mimicked. This is mimicked. And the other IP is called control IP addresses. Control means like how you will administrator. Yeah, how we will administrator the storage system. Yeah, like it's like a like how we will manage the storage system. So what the IP you see here? Yeah, what is the IP you see here, right? So this is like our management plane addresses. So that will be always different because there are two entities, right? So this guy, he will have one management IP address. He'll have one management IP address. Only the data part is mimicked. So data part will be always reachable everywhere. But that the discovery of that control plane, that is, so there are two different addresses. So that's why we can't, when this down, right, even though the data is being served, but we will mark this backend as down. So yeah, did I answer the question, or maybe I don't know?
Yeah. I got your point. I was just thinking like why someone would prefer this over replication. Like I understand one or two things, but like you would like to implement a whole new, I mean, is this currently supported with OpenStack, like the Metro cluster?
Right now it is supported when both are active supported. Like this active, it's working, no problem there. But when there's a disaster happens, when the disaster happens, and he starts serving data to all the clients. So that time what happens, like our Cinder service, right? We mark, because we always try to connect to this control IP address. We know the site is down, so this IP not reachable. So we mark the backend as down. And so the workaround we gave to the customer is, customer will come and he will update the address from 10, right? He will come, update this to 11.1.2. And here he will come, he will update the MySQL vServer -MC. These two updates they will make. That's how they are making this working. But changing the configuration every time, right? They don't like it. So they want something to be there and to automatically handle this situation in Cinder.
Yeah, I'm just thinking like this.
Yeah.
Is from an end user perspective, this is starting to sound more like same as replication. Like if I am using a NetApp solution, then on what workload or what use case you will recommend me a replication feature or the metro cluster feature? Like what I am still trying to find out the main differences between the two for production workloads.
Okay. So metro cluster is maybe very expensive because you are mimicking all the configurations. The example, whenever the banking people, right, the banking, especially that BN Paribas, maybe a few banks, and they want everything to be available always, right? So for mission critical data, and those customers will go for this kind of implementation, and so they don't want to see any downtime, they don't want to see any loss of data, because always the example, this is our banking application, right? The application should always get data from the backend. So those customers will go for metro cluster. And the other way, that sync mirror, right? So there and all, it's a replication. And so even though we call like we can recover, but the recover procedure is always manual. Or maybe if you have scripts with you, right, you can detect and that, as I mentioned earlier, the host side, right? So we should have somebody called mediator, or we should have somebody called somebody should watch, and so he will make this secondary as primary. So something should happen manually there, yeah. Or by script, something you have to automate. Today, Commvault, some applications, they are automating this process. But yeah, so the difference between that, only these two things, Rajat, yeah.
Okay.
So to add to the server point, actually, so metro cluster use cases, so it's between the two different data center. So suppose that you have one data center in Delhi, other data center you have in the some kind of Mumbai, actually. So it's kind of in the different city. So you want to replicate your whole configuration, whatever data center data you are storing here, you want to back up that one too with the same time, with the same means data is written in the same time in this one data center and other data center. So in case of disaster recovery, something happened within that city or something, so your data might be lost. For that one, you have a backup in the different city kind of things. But in the snapmirror kind of thing, that sync mirror, it's on the volume level actually. So whatever data you are writing, the volume, it can be retained in the same data center. You're replicating that same data into a different data center. So suppose that your volume or something aggregate is full, because of that when your volume went down. So you have the secondary volume, which you can map to your client and you can start writing the data. So these are the two different use cases for the different application we have actually here. Yeah.
Okay. So there the replication is on a LUN or volume level, but here it's on the cluster level. And
yeah, cluster level.
Right. Cluster level or whole data center actually we're replicating, we can say. Yeah.
And are these two data centers serving the request, or is just one serving the request, and in case of disaster recovery, we move to other, like?
Yeah,
because you mentioned HAs, right?
Correct. Yeah, if you look at, maybe if you look at this, my site A, and look at this SVM, this is my this is what Cinder is using, right? So this is running. So this is serving data. And you look at site B, right? This is my site B. So this is my mimic. So you got here SVM 0, right? So I got MC, but this is a stopped state. It means like only like this is the one serving data. If you look at site B is serving data for this one. SVM1 is serving data, but here it is kind of stopped here. So like both of them are having both the things. All the data is there in both the site A, site B cluster. Basically 50% of space is wasted. Okay, but this is a normal situation. Okay, that's how like both of them are. There's no problem. So if you look at when disaster happens, right? So example here, now the switchover happens. Switchover means the disaster happens. So cluster B went down. So that one city, some earthquake happened and things gone bad, right? So now if you look at this cluster A, the site A is serving both. Look at both of them running. At the beginning you see like one is stopped, right? So now this is the data for site B. But if you look at right here, so this is the data already there in site A, but this site B data kind of mirror to site A. So he is serving data to that client. Okay, yeah, that's how it is. So now the cluster B, the site B is totally down, and so this is how it is working. Yeah, so everything has happened automatically at storage system layer, and client side, nothing to be worried about.
Okay.
Yeah.
Yeah. I see the difference now. Okay. Yeah. Thanks for the explanation. Um, yeah. Again, sounds good to me. Just one thing
Yeah.
I have, like, so NetApp has a lot of proposals this cycle. So at least I want it to be prioritized based on what is being demanded on priority, like based on that, so we can focus the reviews accordingly. Like, to me, the NVMe with SVM sounds important because it's blocking the usage of NVMe. And these features, like, based on how, like, I think the last topic you presented today regarding the ASA-R2, I think
Yes.
it's a whole new cluster and it's just released, so it might not be very important to get that implemented. I'm not sure. I'm just saying, like, we can prioritize things based on how important they are.
Yeah, ASR2, and yeah, we are putting our best effort, and even the amount of work is huge, and so we are trying to do that in the current release. Maybe if not possible, right? So we will stretch it. I mean, we will extend that to our next F release. Okay, and so it depends on, like, because we need to do some architectural changes there, right? And yeah, so ASR2, the plan is for epoxy, and yeah, worst case, yeah, it will go to F release, but we have to start doing the work now, Rajat. Yeah. And
Yeah, you can continue with the work, just based on the merging and release of the feature. Like, we can get the important ones first.
Yeah, I agree. We don't want to raise all the patches at the end of the cycle and bombard all of it. Yeah, but yeah, we have to prioritize, and yeah, we will start raising early so that we will have some runway to get all these features in.
Yeah, all this sounds good to me. If anyone has any other concerns.
Thank you.
Okay, then we can move to the last topic we have for today. It's Jan's DM clone target, and I think we mentioned, like, if we have some demo ready, you could show us and we can understand better, like, how this driver is going to work with OpenStack. So Jan, you can start.
Yes, so I've prepared something which hopefully will clarify things a bit, and just give me a second, please, to share the screen. Yeah, it seems to be working. So I hope everybody can see that. Yeah, so what I've prepared is a 3-node virtualized OpenStack cluster with Cinder, and prepared the DM clone driver as one backend with a volume type local. I've deactivated the Nova Compute and Cinder volume service on one of the nodes, so we only have to concentrate on 2 nodes, which I've logged into at the top right and top middle. And currently, I've got a watch running there showing the DM setup status, and I'm just I'm filtering some of the results because there's also a Ceph cluster running with encrypted OSDs, so we don't have to worry about those. And then I also show the virtual list, so we have an overview of the instance and where of the instances and where they are running. Currently, I've prepared one instance, a Cirrus instance, and I've logged into that at the bottom middle screen. It's just a standard Cirrus instance, and it's currently being booted from volume, and that volume is already provisioned on the DM clone local backend. So as I said, I've got volume type prepared called local, and that's just configured to use the local volumes backend.
So yeah, sorry to interrupt. So which deployment tool is used to configure this? Is it DevStack?
No, this is based on Collar Ansible.
Okay.
So everything runs in containers, but shouldn't be a problem.
Yeah, I'm just trying to understand, like, because there are 6 screens, I'm a little bit confused. So we have a multi-node deployment for this, like.
Yeah. So 3 nodes. As I said, I've deactivated, or what one is running. It's all hyper-converged. So there's 3 nodes, all control plane services running on 3 nodes, and they are all also acting as hypervisors, and also as it's needed for this driver, acting as a volume host. So they're all running Cinder volume service. But I've deactivated the volume service and Nova Compute on the third node, just so it will be easier to follow around. So I don't have to show another screen showing the third node. That's just left out.
Okay. And you have created an instance from a bootable volume, and now you just want to like live migrate the VM. That's the.
I'm going to first. I've only prepared this because I wanted to show that it's possible. So I'm going through volume creation and volume attachment in a minute, and then we'll do live migration in the end. That's what I thought, at least. I just quickly wanted to show the configuration, because you were asking about that earlier. So there's backend configuration here for local volumes, just referencing the driver, and since it's based on the LVM driver, it's got all the LVM options. It's configured to use the volume group called local, and you can configure the target helper, target protocol. I've only tested with iSCSI in this environment because I don't have a virtualized environment emulating NVMe's, and I didn't have a hardware lab set up yet. So I've only tested iSCSI, but in theory it shouldn't matter because it's all the Cinder LVM driver doing all the heavy lifting. So anything that works with Cinder LVM should work as a volume transport with this driver as well. And
so
there are a couple of
So we provide the functionality to have NVMe TCP with LVM, so that's also possible. And one other thing is, like, the target helper we use is LIO. TGT we have stopped supporting or something. But yeah, these are just minor things. Yeah, but you can continue. Sorry.
Okay. Yeah, I haven't tested with LIO actually. I hope it works. It should. If I've done everything right, it should work. So, and then there's a couple of added options for the DM clone driver itself. So there's one option to define which volume group to use for the metadata device, which needs to be created. It makes sense to put this on another fast device you have, because if you think about it with the DM clone target, for every write you do, the metadata has to be updated. So if you do a lot of small random writes and put metadata and the volume on the same backing storage, then it's going to slow things down. But if you separate that and put the metadata on a fast storage device, then this shouldn't have a lot of impact. Yeah, there's a fixed metadata volume size which is used currently. So I didn't yet implement any automatic sizing. So in theory, it increases with the volume size and with the options you can give with the clone region size. But this I've configured to 16 sectors, which is I think the minimum I could use, and it's been enough right now for testing. So there's room for improvement here, but currently it's just a fixed option. And these are just options which you can pass straight through to the DM clone target. So yeah, we're probably don't need to go into a lot of details here, but these are things you can configure in the clone target. There's the region size, which is the unit DM clone uses to copy data. So region right now is 8 sectors, so it maps to 4K blocks, which is the default. You can configure it to not pass down discards. Yeah, as you said, the hydration threshold you can configure that, and the batch size as well. So, but that's just going to be passed through as it is. Right. So let's put this up again. So we have an overview, and I'm going to create volume create type local. So right now this just goes to the scheduler, and it will pick just any host which is suitable. So right now it ended up on this node. Let's call it node 1. And as you can see, there's 2 targets created, and one is the actually one is the LVS, which is created by the Cinder LVM driver, and the other one that's created is it's a linear target, which is just set up on top of the LVS. So as I said, after the DM clone finishes, we replace the clone target with a linear target. So that's also for consistency. This is also where we start with this driver. So when I create a volume, it always has a linear target on top. Actually, I've mixed it up. So sorry, I've mixed it up. This is the target from the LVM, and this one here is at the bottom is the one I create on top. It's called I've suffixed this with handle. Don't know if that's a good name actually. So yeah, and probably show the table as well. So I said the handle, that's just a linear target, just spanning the whole range of the underlying volume. Okay, so set up the watch again. So now when I'm going to attach it, I'm going to go through what's going to happen, because it's going to happen too fast to talk to in parallel. I hope we can follow it. So the volume is now on the other node. The instance is running on node 2 with the boot volume already attached. And what will happen is once I'm triggering the attachment, there's going to be a volume. It's going to look at the connector which is passed. And if it's not local, then it's going to create the volume, a new volume on the node of the host. So we'll see on this node 2, we'll see another volume appear, and that's going to be set up to be based on a clone target. A connection will be built, will be built up to initiate a connection to the target on node 1, so that the data can be copied, and the hydration will start immediately, so it will immediately start to copy, and we will see the volume pop up, and we'll also see that, or we probably won't see it, but the volume objects, so the volume identities, will be immediately switched once the clone target is set up. So the newly created, or the volume we see here, will be pointing by a name ID to the other volume. Is that clear how it works? I hope it is.
Yeah.
It's like volume migration, actually. Just that it finishes before there's any copying, because it's done lazily by the DM clone target. Okay, so let's see. Instance is called Cirrus, and the volume is test 1, I hope, yes. See how that works. All right, so Nova accepted that. Yeah, so we see here that we've got another volume created, and it's also appearing here in the volume list. And once it's the volume objects are switched, I set the source volume to maintenance, because it shouldn't be messed with. So what we can see here is we've got a new or 2 new targets, one for the logical volume itself, and the other one for the clone target on top. And it's already starting to clone, as I said. It's copying. You can see here it's copying regions, yeah. What we can also see is that it appears on the node immediately, and we should be able to immediately use that volume, use the correct one. So yeah, to do that actually. So we can immediately mount that and start doing things with it. Right, so that's there. And all while it is still being copied in the background. So if we start writing stuff to it, I'm not sure. I haven't done it. I haven't prepared anything useful here, actually. So I'll just write some stuff. I don't know. Let's add some data. Let's say, so that's already there. And yeah, so it's immediately usable, right? So going local now on this node, and the data that's left, I mean, we didn't have any data yet because it's a new volume, but everything that used to be on the volume is being copied in the background.
So did we create the volume in one node and then attach it to a VM in another node? Is that what we did right now?
Yeah, so the volume was created on one node, and it was attached on an instance on the other node. Yeah.
Okay.
Yeah. So the other case where everything is on the same node is trivial, and the driver will just return the local object immediately.
I see. And
yeah,
does the live migration of the instance also trigger this same thing, like DM clone and?
Yeah, it's a bit more complicated, because for the live migration scenario, it will set up. Well, it's a like a multi-attachment scenario, and we have to make sure that on the destination we set up the clone target so it is accessible, so that you can start writing to it once the instance is transferred. But we have to disable hydration, because otherwise, since we don't actually know when the instance is going to be switched from the source node to the destination node, it could be writing on the source, but once it's switched, it will start writing on the destination. So if we enable hydration before that, we might mask some writes that are done on the source node. So regions might already transferred to the destination and might be overwritten on the source node. So we will have stale reads, stale data on the destination. So we have to make sure that we start the clone target with hydration disabled. And then once Nova finishes the live migration and the instance is running on the destination, it will disconnect the volume on the source node. And that's detected in the driver. And the driver will then enable the hydration when the disconnect on the source node happens. Or if the disconnect is triggered on the destination node, then everything will be rolled back.
Okay.
So
And I think Nova handles most of it. Like, it creates a new attachment on the destination. It detaches from the source after the live migration is complete. So we just need to handle those cases on the driver side. As you said, like, disable hydration on the multi-attach and enable it while we detach from source. Or like handle those cases. If it fails, then revert back. Okay.
Yeah. So when the setup is done, the volume object will point to the volume to the driver volume on the destination. Right. So it's been prepared that the switch should work out. And so when this volume service on the destination receives the detachment, it looks again at the connector, whether it's the source node that's disconnecting or whether it's the destination, and then decides, depending on the connector, what to do.
Okay.
So hydration finished here, and then, as I said, there's a periodic job and running in the driver, which just goes through all the volumes which are currently transferring, which are in the process of being hydrated, and then checks whether they've finished. And once they're finished, it will just load that linear target again. So we are at the same point we started with the volume, with the logical volume and the linear target stacked on top.
Okay. And how are these two nodes connected right now? Like, is it just Ethernet or some, like, are these connected over IP or some, what is the connection between these nodes right now? Yes.
These nodes, they are virtualized. This is a virtualized test environment, so they're connected. We are a network. It uses just the internal OpenStack network. There's one configured for pretty much everything. Like
Okay.
for all the internal connections, but it should be possible to configure any storage network which you create. So so any network actually, because it just depends on the configuration of the Cinder volume service, right?
Yeah.
So if you configure that to use a certain IP address, I'm not actually sure how it's configured, or a certain interface, then it will use that interface or that address, and also the network.
Yeah, just this case is slightly different. As I was mentioning earlier, like usually the compute nodes interact with the storage array and they generally don't interact with each other. So we don't necessarily require, like they have their internal connectivity somehow, but they don't require a high performance storage data path between them. So that's, yeah, but again, that's a deployment related thing, how they want to configure things.
I think, yeah, you're pretty free in how you want to set up this deployment, whether you want to use an existing network connection and maybe use a dedicated network for that, or if you want to do traffic shaping, you could set all this up on the node and should just work.
Okay.
Okay,
Yeah.
so I can show the live migration if you want to.
Yeah, that would be great if that is working right now.
Yeah,
Okay.
it's working. So as I said, it will set up the clone target on the destination, and we should see the instance moving over. So just have to make sure that it's live migration this time. Yeah, that should be it. So it should again see the new volume connected on the created on the other node. Might take a while till it's processed. Oh, actually, result is an error. So VM state. Okay, sorry. Yeah, I did a non-live migration. So before server, what's that? Confirm, resize confirm. I think it's resize confirm, right? So I did previously, I forgot to do a live migration, and so I should yeah, okay. Cannot confirm instance. Oh, so it's active. I'm not sure what's happening right now. So the first confirm actually worked, I guess. Just told me that it's deprecated, but yeah. So yeah, VM state is active. Okay. So should be able to do a live migration now. Pay attention to the output. Okay. No. Output. Just list the migrations. But yeah, you can see that there's the volume set up, and it's set up the clone target, and you can see probably that it's set up not to hydrate. And so both of these volumes, and yeah, so the instance just switched to the destination node, and then it enabled hydration, and now it's copying in the background. And yeah, so hang on. So there we go. We can still have access. So actually, I was.
How did you know like the hydration is disabled? Like, are these 104 options signify those values? Like,
Yeah, it says it's set no hydration as an option. So we can probably go have a look at the documentation. So that's volume. Hang on a second. Core args. Yeah, it's core arguments. Now optional feature arguments. So where you can set no hydration, and that's what it showed in the output. And then you can just go ahead and enable that by sending a message via DM setup to it to enable hydration. That's what the driver does in the background.
Yeah. Okay, I missed that part. No hydration. That's why I was confused. Like,
yeah, it didn't take long for Nova to migrate the instance, so that was just a short period of time. We have to wait for the hydration to finish now. So as I said, while it's hydrating, I don't want to chain. Oh, it says I have problems with my network. No, it's gone now. So I don't want to chain. In theory, I could re-export this clone target via iSCSI or NVMe and set up another clone target on another destination node. I could chain all this multiple times, but I really don't want to do that. So I think it's best to just not allow any actions, or just don't perform any actions on the volume while it is hydrating. So in order to avoid this complexity. So
yeah, I also don't think people live migrate this frequently. Like usually it's when one of the compute nodes is having high, I mean, it doesn't have enough resources to hold the VM, then we want to live migrate or some disaster recovery, but it's not like they keep moving every 5 minutes. So we should have enough time for the hydration to complete at least.
Yeah.
But the way this hydration is happening, like how does this copy the data, and do you know about the speed? Like I'm not able to estimate how much.
I haven't done performance testing on the speed of the hydration actually, because I thought it wouldn't make a lot of sense within this virtualized environment. I think it's best to be tested in a hardware setup actually.
Yeah.
So I'm not sure, and it depends. You can configure the region size. So I would imagine if you set up larger regions, that it would be we would copy faster, but it's probably well, it's going to be more latency when you read a remote region, I guess. So there's a trade-off there between throughput and latency, I think.
Okay, and I think it also depends on the network we use. So yeah.
Yeah, it should. Yeah, so in theory, if you've got fast network, it should be faster. Yeah. So as I said, this is virtualized. So there's not going to be any reliable numbers which would mean anything, I guess. But yeah, I haven't done any actual benchmarks of this.
Okay.
So
yeah, no, it's just curious. Like it's not important. The detail is not that important.
Yeah. So one thing to keep in mind as an operator is that if a user attaches a volume, then that volume is going to be usually that volume is going to be hydrating, so you can't live migrate the instance at that moment. So you have to work around the user sometimes if you want to use this.
So if the volume is hydrating, and if I request a live migration request, then during the initializing the connection on the sender driver side, is there a way to know that the volume is hydrating?
Actually, I think I'm just raising an exception right now, if that's the case.
But what's the condition for raising that exception? I mean, do we have the knowledge like the volume is hydrating? That's my question.
Just let me think about it for a moment. So, well, yeah, so you request the live migration, and then Nova will request all the volumes to be attached to the destination node. And that's going to fail because I'm not sure. I think I was checking for that explicitly. Or currently, I'm just checking the metadata whether there's still a source set up on the. So as I think I've mentioned that I need a side channel to communicate certain things, like the source volume of the newly created volume on the destination. So currently, I'm just checking whether that metadata exists, and just fail when it does. That's probably
yeah. Yeah, I was just curious if we didn't because you mentioned the maintenance state, so I thought that shouldn't be the condition because we agreed like we can use we can just fail and use user messages to notify.
Yeah. So I think that's definitely the way to go. I've currently it's still setting the volume to maintenance on failed on failed actions, but I'm going to remove that. That's no problem at all. Because I didn't know how to communicate back to the user, but Cinder just does it automatically as I've run. So yeah. But yeah, I think I could be able to demo that just in a minute, actually. So hang on, let's do this right. Create the file system here. So unmount that before I'm going to detach the volume. So yeah, so we see that's it's detaching. Should already be detached, but the API is just slow in this setup, in this test setup. I will just take 2 seconds to update. It's already gone here. Yeah, so it's available again. Let's do another live migration. So we have this setup of so we can do the attachment and then try to live migrate, right?
Yeah, and while the live migration completes and the hydration is in progress, we will try to live migrate again.
Yeah,
I think that's the okay.
Yeah, and then we should see that it fails. So sorry, we missed the disabled hydration again. I just went too quick.
Yeah, no worries if it shows there. So right now you're attaching it to okay, yeah. Right, if you perform live migration now, it should reject it, right?
Sorry?
If you perform live migration on the VM right now, it should reject it, right? Because the volume is hydrating.
Yeah, so once that's that's hydrated, it will be reset to the linear target.
But
So we can,
right now, if you do live migration on the VM, so it should fail.
yeah,
based on
right
the
now it should fail. So if I do that again, it should, yeah, we can, yeah, you're right, we can already see that. Should fail because we're probably not going to see anything actually unless we watch the logs for the raised exception. But we'll see. So I'll just have to think about this quickly. So it's going to send the attachment request to the Cinder volume service on this host, right? So let's just quickly Cinder volume. There should be yeah, so one see the exception here, and says that the volume is still migrating. Yeah. So
yeah, so this failed on a previous check in the volume driver itself. Okay. Yeah, then we can only test it with that. Yeah, sorry, I was just trying to create a new test case, but I think that doesn't work.
Yeah, so it fails immediately an initialized connection if the volume is still migrating. Well, if the volume admin metadata says that there's still a source volume, which is going to be removed in the cleanup. Yeah. So maybe another thing. So we've seen that live migration failing while the volume is still transferring. Maybe another thing which is different with this driver is that so I've implemented host assisted volume migration, and so that's going to run on the source host of the volume every time, and there's not much I can do about this at the driver level. And this is where I need for certain actions, I need to communicate that I want a remote connection and not a local one. Because if I requested or if I implemented a local connection with this driver, I could transfer the newly created image on the volume on the destination node to the source node, and there would be no migration actually happening. So and the same with the connection to the source volume. So at certain times, I need to be able to communicate that I need a remote connection. Probably backup, the Cinder backup service is probably another candidate for a remote connection, but I haven't really looked into it yet. So some things just need to be done remotely, and I've used the pre and post volume copy hook. Don't have the exact names right now. I hope you know what I mean. So there's two hooks in the driver for before volume copying and afterwards to set this flag in the admin metadata that I want a remote connection, and after the copying is done, the flag is unset. So there's probably a lot of places where there's a need for volume locking, which I actually haven't done yet. Because I haven't looked into where Cinder does the volume locking for the driver and where it's probably necessary to set a lock in the driver.
So if you reference the remote FS driver, which is the base for all file system based drivers like NFS or so that I think implements some locking in these initialize or maybe even create volume not create volume, but I think on operations involving volume like extend or clone, on that, I think based on the volume ID, I can find an example for you. Give me a second. So if you take a look at this example, it has a decorator that implements this lock, and the locking is based on some prefix and the volume ID. So there are not race conditions with multiple operations being performed on the same volume.
All right, so I define an inner function and just decorate that.
Yeah, so where exactly would we like to have a lock in this driver? Like what possible race conditions are there?
So I think when you start the attachment, then it creates the volume on the destination node. I think there should be a lock for that volume on the destination node while the initialized connection is still working, because I mean, I'm not sure. Cinder probably locks the volume while it's creating, but after the creation is done, you could actually do actions on this newly created volume while this driver in its initialized connection function is also still working with this volume, right? So if we look at the initialized connection, it does it calls the create volume on the remote host, and then that sets up that also sets up the clone target, and then the source is looping, and at some point it's done creating, and that's probably when, if there's a Cinder lock, I suppose there's a Cinder lock, that's probably when the lock is released from Cinder, but there's still so we're still working with this volume, and it's not going to be set to maintenance. Before that, there's probably a need to lock that at that moment.
Okay, so basically during hydration, we don't want any operations to be performed. In the initialized connection, we handle it by the admin metadata with the source field. So is that enough for that? Like maybe we can create a decorator and have this condition of this admin metadata and wrap it around all the operations. That should not work with the volume, or
Okay, so you mean that probably the driver could check on that field, like I actually already do in initialized connection.
Yeah, just
For the
like
source.
generalize it for all the operations.
Yeah, that could work. Yeah. Because there's this small window when the created volume actually when the create volume flow finishes, it will be available, and then I will set it to maintenance inside the driver. I don't know if that's actually a good thing to do from the drive now. I see you shaking your head now. Okay. Yeah. So
Nova already logs it by creating a new attachment on that volume. So it moves the volume to reserved. So that way, no operations could already be performed on that volume until the live migration completes. The destination volume, I think, stays in reserved, or I think in use. But Nova does handle that case to not be able to perform any operations while live migration is in progress.
okay. Yeah. And for normal volume attachments, is that probably the same?
Yeah, so Nova has multiple services, like we have Nova API, scheduler, conductor, compute. So it passes on to each layer. So in the Nova API, what we do is in case of attachment APIs, we have 4 attachment API on the Cinder side. We have attachment create, attachment update, attachment complete, and attachment delete. So attachment create just creates a database record on the Cinder side. So it does nothing else. It just moves the state from available to reserved and creates a database entry for that attachment record. And that state, we use it to log the volume, like reserve that volume for that instance. So that call happens in the Nova API layer. So Nova, just right after starting the operation, reserves that volume for it. And later, when it's finished with like all the networking and all the image and the libvirt stuff, like creating the VM, and then when it moves to the volume operations in the Nova Compute service, then it does the attachment update, which actually maps the volume to the host.
Mm-hmm.
So Nova handles this like that, like reserved until it performs its own operation. So the volume is reserved for that VM, and then later updates the attachment, and so it can use that volume.
All right. Yeah. So in that case, there's no need for locking because it's reserved. Okay. Yeah. And
We should have seen issues if there were any in that workflow, like if the volume state was not sufficient, then we should have seen people complaining about like volume being used for other operations when it's ongoing, this thing. So that should be handled. And the case that you mentioned, like the hydration case, which is specific to this DM clone, that we can handle in the driver, I think.
Yeah.
So
yeah, possible. There's one other place. There's the periodic job which cleans up the clone targets. So that goes through a list of volumes, looks for the admin metadata. So whether it's a candidate for being in a state where it's being transferred, and then it will start to check the device mapper target, whether it's a clone target and whether that clone target has finished hydration. And if it has finished hydration, it will clean up, load the linear target, delete the metadata, delete the source volume, and do all that. So I'm thinking that maybe it's best to also lock that volume there while this action is happening.
You mean when it's cleaning up the source volume, then we should have lock in that operation too. But that volume from Cinder perspective doesn't exist anymore, right? So one question, like to just clear my understanding. So once the live migration completes, Nova initiates a detach request from the source for the volume. So during that time, we cannot detach actually because the hydration is still ongoing. So how do we handle that case in the driver?
When it's detached on the source, I don't think there's anything to actually do in that case on the Cinder side, because it's a local attachment. There's no need to clean up to clean up or to do any specific action to in terminate connection, because it really just Nova detaches the local block device from the instance, and that's all there is to it, actually, I think. So
Okay.
I haven't implemented any action there on that case, other than triggering the hydration on the destination.
Okay. And how do we know when the hydration is completed? Like, how does the Cinder driver react to it?
It checks. Let me start an attachment again, so we can have a look at the output of the clone target. So I'll just resize that. So we can see that, hang on, within the output of the clone target, this is the amount of regions which have already been hydrated, and this is the total amount of regions. And this flag shows whether it's actively hydrating. So in the driver, it just checks whether all regions shown here are actually hydrated. So whether these numbers are equal, and this flag is 0. And if that's the case, then hydration is completed, and then it will start the cleanup.
Yeah, but there should be some event triggering that, right? Like to do these checks.
Yeah, it's there's no event. It's time based, so it's a periodic job, and
Okay.
you can. I haven't done that yet, but you should be able to configure the interval for this periodic job. So because it needs to list all the volumes on these for this host, for the Cinder volume host, and go through each of them to see if it's marked as being transferred in the database, and what the actual state of the clone state is. So if you imagine you have huge host with a lot of volumes, then this might have performance impact. So it should be configurable to set this. There will be a trade-off between the volumes, actually between the delay after clone completion and resetting into a linear state. So maybe the clone will take longer than it should, but yeah, if you increase the interval, but it will also reduce database connections or database queries, actually.
Okay. And is this the same periodic job that? So this job is running on the destination, that is checking if all the hydration is complete. Then we will remove the metadata from the destination volume. And is the source volume cleanup also part of the same periodic job? Like,
yeah.
okay.
So let's see if that's so where is it? The migration monitor. There it is. So this really just it fetches all the volume objects from the host, and then just again checks for this this magic volume admin metadata, so to see whether the volume is actually being transferred right now from the database perspective, and then it goes through the status and checks whether it's actually a clone target, just to be sure. Throws an exception otherwise, and then it goes through, as I explained earlier, it just compares regions to see whether it's all done, and then proceeds to load the linear target, delete metadata. Okay, I'm doing something with attachments here. That's probably just a safety check. I'm not sure right now. I have to look that up. It gets the connection from the attachment info we have for the connection to the source volume, and then just disconnects that, and then calls out to the RPC RP to delete that attachment. Yeah, okay, and then delete the volume. And well, this is probably not necessary anymore. If as I said, right now I'm setting the volume to maintenance if there's some actions, but we've decided to not do that, so this can go actually. So this would just reset the volume state. But that's
Okay.
so that's not needed anymore. So yeah, that's what it does. So this is running on every Cinder volume. Or it's a periodic job which is started in the do setup method. So it's run on every Cinder volume service running this driver.
Okay.
And it will just check its own volumes to see whether any are done hydrating.
Okay. And where are we cleaning? Like we are removing the attach. Okay, I see the delete column. The RPC call.
Yeah.
Yeah. We might need to review the driver, because I think there is certain level of abstraction that we maintain between the driver and the other layers of. So this RPC is imported from scheduler, I guess. The RPC.delete volume, or is it the volume RPC?
It's the volume RPC, yes.
Okay.
Yes. I'm not calling out to the scheduler No, I don't think I'm calling out to the scheduler ever. This is the volume RPC, yeah.
Even the scheduler needs to update, or maybe the volume service does that periodically, but so scheduler maintains a local copy of all the total capacity and everything. Yeah, but we can take a look at this in the review. I think this is a very niche use case for this driver, because I think it won't be used for I mean, it will be used for specific cases, and a bunch of features are also missing, like extend or all that. So I think a lot of things shouldn't be a blocker for this, because it will be used in a very I mean, at least the deployer will know its impacts before using it for, as you mentioned, like the Kubernetes workloads for etcd, and over the local attach LVM, it does provide significant improvements, at least for the live migration case, which is really good. So I think overall it sounds like a good idea to me. We can look at the code and once you propose the patch for it. But yeah, overall it seems very promising to me.
So yeah, this, as I said, it's like I will consider it's a proof of concept. So I'm working on the spec right now, so we can probably discuss a few things like the proper side channel to do to communicate certain aspects which are required, and then it should also be clear which RPC calls are called from the driver. So it does a lot of communication from one Cinder volume service to another Cinder volume service. So like volume create, volume delete, yeah, attachments, updates directly. So
yeah, usually when we migrate the volume, like even if we are creating a copy, then after the live migration, Cinder just deletes it. But this is a special case where we require the source volume for the hydration case. That's why it gets tricky to clear up that device. The scheduler case I'm mentioning is like, so there is a time interval where the Cinder volume service updates the scheduler. Like these are the actual driver stats. Like this is the total capacity, this is the free capacity available, all these things. But until the driver updates the scheduler keeps a local copy of it. And if that goes out of sync, we might reject requests. Like let's say there are 10 volumes, but I think yeah, so yeah, as I was saying, so there might be that the scheduler thinks there are still 10 volumes in the source node, but they are hydrated, they are removed from the driver perspective, but the scheduler doesn't know about it. So it's constantly rejecting the request until the stats are updated again. So that was one of the case I was thinking about. But as I said, yeah, we can work through these things and see what would be the best solution for that.
there's probably no way to trigger an update on the scheduler from the volume service.
We can actually, like after we do this delete, we can call the update volume stats method, which updates the scheduler, which is one way. Yeah, we can work on that. And are you also on IRC?
Yeah. I think my nick is in the Etherpad. Just my name actually. Yeah, Jay Horstman.
Okay, so we conduct weekly meetings in the OpenStack meetings all channel. We are on OFTC so network. Then every week at 1400 UTC, I can redirect you to the Cinder meeting space.
I've been in a meeting before, in a Cinder meeting. So yeah, I can join definitely. Yes.
Okay, yeah. So that's a good place to clear out the doubts. Also, we do a video meeting at the end of every month, which makes it easier to communicate these kind of ideas, like the demo that you showed couldn't be on chat. And we also have mid cycles. I think every 2 or 3 months we meet for 2-hour session, and there we track the status of all the things that we have been working on. So I think there are a lot of places where we can collaborate on this after the PTG. But yeah, right now, at least to me, I don't know, we don't have the whole strength available this time at the PTG. A lot of members seem missing, but yeah, they are available on the IRC meetings or the mid-cycle, so they can also provide their ideas. But to me, it looks good as of now.
Okay, yeah, that's good. Thanks. So I probably need feedback on certain things every now and then. So it's good to have places to talk. So yeah, sounds good.
Yeah.
Is there anything else you would like to see? Anything I haven't shown yet? I think I've shown the basic stuff or the most complicated aspects actually.
Yeah, and I didn't forget to record it, so the team members that are missing, so they can watch it. I interrupted you a lot of times in between, so they might not like that part of the recording, but yeah, at least we have some part of the demo there. So yeah, if they have any queries about it. But yeah, I think this looks good. I think these are the main operations that we discussed in the last session, and they seem to be working fine in this demo.
Yeah. So that there's probably a lot of room for to actually do stress tests on this, like do heavy I/O, read back, see whether it checks out. I think from the theory I have in mind, everything should be fine even during live migration. But I'm not sure if there are actually corner cases where it might fail. So I might have to still do that. I'm not sure if there's a good tool to do that actually.
Yeah, as I understood from the documentation page, like if I'm trying to write, like, so if the volume is still hydrating and I'm trying to write to the destination, then what it does is it copies the region from source to destination, the one that I'm trying to write on, and then performs the write on it. And if the write is the same length as the region, then it just overrides that. But if there are certain parts of it that I want to update, then first it copies from the source that region to the destination and then modifies that part. I think.
No, it's actually well, at least how I understood it is that if you do a write to a region that has not been hydrated yet, then the write will be made and the metadata will be updated that this write can be, or this region can be found locally, and it won't be hydrated at all. So
yeah, but
because the data is stale on the source node, you've overwritten it, right?
But if the write is smaller than the region, like if I'm keeping a region of, let's say, 64 MB or something like that, and the write is smaller, in that case, we will need to hydrate that region, right? And then perform the partial write on that region, like whatever the write is being performed.
That's an interesting question. I haven't thought about that.
I mean, that's what I understood, because these are the two cases. Like one you mentioned, like if I'm overwriting the region, then it just overwrites it. It doesn't need to be hydrated because like there is no purpose for it. But if I'm going to partially write on that region, then it needs to hydrate that on priority and then perform the write on it. At least that's what I understood. But yeah, you can correct me.
No, that's I wasn't thinking about this specific case. So no, that's probably correct. Actually, I have to say I don't know. It's probably best to size the region according to the block size you're actually using. So then
Okay.
this shouldn't happen if you size the regions to the actual block size you're using on your block device or in your file system.
Yeah, I think that would be the best case. Like,
but yeah, so yeah, there's room for conflict there because I've made it. You can set that the region size as a driver option, but I mean the user is free to choose the block size they want to use. So there's room to misconfigure this to not be very performant, I guess.
Yeah, I mean, some customer is using this and then they see performance impact and then they increase the size of the region or change the block size of what we are trying to write in those scenarios. But yeah, I think those are very edge cases that we can think about. But yeah, as you said, like if we configure the same size for both, like it should just work fine. So there shouldn't be any conflict there.
Yeah, I think so. And then it just won't hydrate this region or block at all, and it will just write local.
Yeah, in that way, it's pretty smart. Like even saw in the documentation, there were a bunch of options in the DM part, like DM snapshot, DM thin. All those options were considered before implementing this DM clone, and I think it's very well thought out. So we don't have to do a lot of like considerations in these cases, at least.
Yeah. So I also assume that that it's been used and it's been tested and that it will actually work the way it's described to work.
Yeah, otherwise we can just rely on the RHEL team to fix things.
Yeah.
Yeah, thanks, Jan. It was really good. The demo and all the things that you have shared about this.
Yeah, thanks for watching this demo and for asking good questions. I think they help people understand what's going on, because I think it's rather complicated to explain and to wrap your head around if you hear about it the first time.
Yeah, and generally, like all these things happen behind the hood because Cinder is a abstraction on the storage technology. So usually, like even if you saw like all the NetApp presentations, like they had a bunch of new features, and we are not really interested in knowing how the SnapMirror or any of these technologies work. We just want the OpenStack integration to work with them as desired. At least this one is a kernel level driver, so that's why I think there is more interest to know like how things happen behind the scene. But usually, like Cinder doesn't. I mean, it doesn't need to be aware about all the background things.
Yeah, definitely. So in this case, it's probably better to be aware of the things because it's all integrated into the Cinder volume service now with this driver and not running as an external daemon.
Yeah. Just one more thing I remembered. So, did you attend like one of the event-led session? Like, I think it was discussed yesterday. So I think you were not there. So basically, right now we rely heavily on event-led green threads for our services, and now event-led hasn't been maintained properly, and we are planning to switch to native threads like libraries like async.io or just the native threading library of Python for our code execution. So Cinder volume, I think right now runs as single threaded. And as you mentioned, like there will be a periodic task for it. So I think just that consideration, like right now it will work just fine because like green threads will take care of it. But after the migration, you might need to have some async task to perform that. So just one consideration. But I think so for this cycle, we are not planning to merge any of these event-led changes that might make the release unstable. So we will just be doing planning things. So if your driver gets merged this time, at least we can add that consideration, like how to handle that case. So just to make you aware, this is one of the transition the project is going through.
But so are we possibly looking at a move to async IO, or will it? Because that would probably be to rewrite more stuff than if it was a move to Python threads, I think.
Yeah, so a bunch of options were considered. I think based on the specific case, projects are recommended to use, like, so EventLed used to provide this green pool. Now they are saying just use thread pool executor for that. And like EventLed used to do spawning of like tasks in green threads. Now they are recommending async io.create tasks, which I think creates a async, I don't know, it creates a sub process, a child process or something, what it does. But based on how you want to make your code work, you can consider these options. So async IO is not just the standard, like we need to migrate everything to this, but basically whatever works in that particular case. So we need to first find out the usages in our project of EventLed, and then on a per case basis decide which option would be best for this. Like so for the RBD driver, if you see, like we already do all the backend calls in native threads, because RBD calls librd, which is C native library, and it doesn't understand green threads. So we have been in some issues where we call the C code with green thread and it just gets stuck because C execution uses the native thread. So already there were some considerations made in some cases where green threads doesn't work as optimally, but now we need to migrate the whole code away from it. So it will be on a per case basis how we need to modify.
Yeah, okay, so it's good to know there's probably work to be done then. I guess I'll just, yeah, I'll stick to what is done right now and see what happens with the migration.
Yeah, it shouldn't be a blocker even for a driver. Like we can, along with all the changes, we can also modify a driver later when we do the eventually changes, and it should be fine as it is. Just I was mentioning it because you mentioned the periodic task, so I thought if it will work or not without EventLed.
Yeah, so if there are any more questions, maybe from other people as well who are watching the video, feel free to reach out to me. I think so the driver is linked. You should be able to find me on IRC. So yeah, I'll try to be at the meetings.
Have you added a link to your driver in your? I think it's in your GitHub repo right now.
Yeah, it's in the initial description, I think. It's not in the topic right now, so. That's at the bottom. Topics. So this is the driver repository, other repository where the driver lives currently. I don't know. Do you want me to just add this here? No,
I found it. I decided it. You mentioned like it's in the original topic, so that's fine.
So one is the email to the list. So yeah, so there's my email address as well. So you can find me.
Yeah. Okay, I think so. That was the last topic we had, and we're also towards the end of this. And I think most of the people have left. They might have other priorities to attend to. I will just stop the recording for now.